Hello dear students, welcome to my channel Kaveri Science Tutorials. Today we are going to see class 10 science 1 chapter 1, that is gravitation. So we will see the meaning of gravitation. We have seen in previous standards about gravitation, which type of force is gravitation. First in the chapter, before starting the chapter, we have to know the meaning of force, types of forces, and then what is the effect of any kind of force on the object. So for any kind of motion of the object, force is necessary. For the motion of any object, force is necessary. So force, when we push or pull any object, that is called as force. So applied force is any push or pull of applied on an object is called as force. So there are two types of forces we have seen in the previous standards, that contact forces and non-contact forces. In contact forces, you have seen the muscular force. Example, we lift any object, that is a muscular force. Again, we have seen a frictional force. We can walk on the road due to friction. That is the example, is we can walk on the road. That is the example of frictional force. So these are the two types of contact forces. So there are again two types of non-contact forces, and that non-contact forces are, first is electrostatic force and second is gravitational force. So we have done the experiment of the comb. We have to rub the comb on the hair and the paper pieces are attracted towards the comb, and that is occurs due to development of charge, and that is called as electrostatic force. And again, it is the non-contact force. Without contact, the objects are attracted towards each other. Another type of non-contact force is gravitation, and we all know that it is due to earth. So earth attracts things towards its center, and it also called as gravity, and due to which the things fall in downward direction, that is called as gravitation. So the force exerted by the earth, due to which things fall in downward direction, and the force is directed towards the center of the earth, is called as gravitation. Suppose this is the earth, and on the surface of the earth there is a tree, and that suppose that is the apple tree. So the apple fall takes place in the downward direction only, and that famous story of Sir Isaac Newton we have studied in previous standard. So that the scientist Newton was sitting under the apple tree, and he started to think why the apple fall takes place in vertically downward direction only. So after his thought, he came to the conclusion that the means the apple fall takes place, the earth must be attracting the things towards its center. Therefore the any object falling on the surface of earth falls in a vertically downward direction. So that he was the only scientist, Newton was the only scientist, he has mathematically proved the law of gravitation. Again, he has tremendous work in case of science, like heat, sound, light. We have seen his work in science 1, and we have known about his tremendous work in case of science. So that is about a successful discovery of Newton. Mathematically he proved that there is a law of gravitation, and their earth attracts the things towards itself. So we will properly define gravitation: the force which is exerted due to earth, and due to which the things fall in downward direction, and it is directed towards the center of the earth, is called as gravitation. So that is the definition of gravitation. So we have, in this chapter, we have to see how the means we have seen that the any two objects present on the earth, they attract each other, and that is only because of the force of gravity. So again, the planets are moving around the sun in the universe. Again, in case of earth, moon is a natural satellite of earth, and moon revolves around the earth in a particular orbit, and that it doesn't falls from that orbit, and it is due to which type of force we have to see. So the circular we have to study for the study of planets around the sun, or the study of means planetary motion around the earth or sun. For that purpose we have to see the meaning of circular motion, and we have to do an activity, and after that we will see the important force acting on that circular motion object, and that is called as centripetal force. So the object which revolves in a circular path is called as circular motion. The motion of the object is called as circular motion. So we have to tie one, we have to take one string, we have to hold one end in one hand, in our hand, and another end we have to tie a stone, and we have to revolve that string around our hand, so that what will happen, the stone will revolve in a circular path, and that motion of stone is called as circular motion. So when the stone will release from the circular path, that will fall in a tangential direction to the circle. How we will see? Suppose this is a string. So here is a stone, and we are holding that stone, and we are revolving. So when the stone is acted upon by the centripetal force. Centripetal means seeking towards center. Here also the direction of force is directed towards the center of the circle, similar to gravitation, but it is a circular path. So the object is revolving. When the object is revolving in a circular motion, the force acting on the object along a circular path, and it is directed towards the center of the circular path, is called as centripetal force. That force is called as centripetal force. So it is directed towards the center of the circle, and when the force stops acting, when the centripetal force will stop, the stone will release from the string, and it will fall in a tangential direction to the, so it is a tangent. So the stone will fall in tangential direction to the circle, and tangent is a line which makes 90-degree angle with the radius of the circle. So the stone will fall in tangential direction along a tangential line to the circle. In this way, we can have studied circular motion, and the force acting on the object in a circular motion, and we have to see the next part of the chapter. So we have studied circular motion to study the circular motion of planets and circular motion of moon around the earth. So moon revolves around the earth in a circular orbit, and it occurs only due to the circular only due to the centripetal force. Again, all the planets in the universe which revolves around the sun, they also revolve only due to the action of centripetal force. Therefore, they are that is directed towards the center of the circular path, and they do not fall from their orbit. So that we have to study this type of force, and that force is called as centripetal force. Centripetal means seeking towards the center. Another type of opposite direction force is not given in the textbook, for your knowledge only. That force is called as centrifugal force. When we make butter from buttermilk, so that centrifugal force is directed away from the circular path, and that object's lightweight butter particles are thrown away from the mixer jar. You are taking mixer jar and revolves in the circular path, so that butter particles are thrown away, and the buttermilk remains behind below, and that is called as the centrifugal force. Just for your it is opposite to centripetal force. So the butter particles are collected due to centrifugal force, and it is directed away from the center. So the next part of the chapter is the scientist Kepler and his laws, three laws of Kepler. And Kepler was a scientist who had studied planetary motion, and for that purpose he has derived three laws, and we have to study that laws in this lecture. So Kepler was a scientist who studied the planetary motion, and his first law, before going ahead we have to see the meaning of ellipse and the what is mean by ellipse. So we have to take one cone shape like this, and from that cone shape we have to cut an inclined part of the cone shape, and that inclined surface we get, that shape is called as an ellipse. So ellipse is this ellipse, and there what is mean by focus. So f1 is one focus, f2 is another focus. So these two plural word for these two is foci. So these two are the foci of the ellipse. So what is focus? If the point A, distance of point A from f1 is af1, and from f2 is af2, so we have to add that distance. Same for B point, same, and same for point C. So the distances from that f1 and f2 foci, we have to add that distances, and the sum of these distances is always equal, and that is called as the focus. If the point is there and the distance of the point, any point from that foci to foci, and their addition is equal to the another point, like af1 plus af2 equal to bf1 plus bf2 equal to cf1 plus cf2. If it is like this, then the points are said to be foci, plural foci. So this is about ellipse, and we have to cut that cone shape in an inclined manner, that we get is called as, shape is called as ellipse. So we are going to see first law of Kepler, that the orbit of a planet is an ellipse with the sun at one of the foci. So Kepler's first law is, the orbit of a planet is an ellipse with the sun at one of the foci. Suppose these are the two foci and sun is present at one of the foci, and that is called as, the orbit of a planet is an ellipse with the sun at one of the foci. So first law, so this is the orbit of the planet. Suppose there is a planet is here like this, and that is orbiting around the sun. So the orbit of a planet is an ellipse with the sun. So the orbit shape is elliptical shape, and the sun is present at one of the foci. We have seen the meaning of foci. Two foci are there. From that two foci, at one focus, sun is present at one focus, and that is called as the Kepler's first law. So I will repeat first law. The orbit of a planet is an ellipse with the sun at one of the foci. Again, second law. The line joining the planet and the sun. So this is the planet. So this is the planet, and the line joins the sun and the planet. So this line joining the planet and the sun sweeps equal area in equal interval of time. Suppose to cover this area, so to sweep this area, time interval capital T is required. to cover this area, time interval capital T, and same time interval is required. So in same time interval, the area swept by the planet or the line, or the area covered by the line joining the planet and the sun, sweeps equal area in equal intervals of time. So the time required to cover that area is equal. Suppose it is a 1 hour or 2 hour. In 2 hours, the area is covered here in this position is equal to the area covered in this region. Again, this area AS, suppose this is a point S, SB equal to area CSD, like this, and area ESF, they are equal. So the line joining the planet and the sun sweeps equal area in equal intervals of time. That is the second law, Kepler's second law. So this diagram is asked in the examination, and you are asked to write down the means the law, which is the law to which this diagram is related. So this diagram is related with which law? So it is related with Kepler's second law. Kepler's second law, and you can be asked to you may be asked to state the statement of the law, and in this way you can answer. And 2 to 3 questions are asked for 3 mark, and very easy to answer these types of questions based on the diagram. So in this way you have to write the second law, and the diagram is, many times this diagram is asked in the examination. Last year also this diagram is asked for answering the questions. 3 questions are asked and you have to answer, or in case of diagram based questions also these types of diagrams are asked. So mean distance means what? We are going to see the third law, Kepler's third law. So for third law, we have to understand the period of revolution. What is meant by period of revolution, and what is meant by mean distance from the sun. Suppose this is one distance AS, okay? So it is AS plus it is another distance CS. So it is another distance plus it is another distance ES. So we have to take the distances and divide it by 3. That is called as mean distance. So we have to take the mean distance from the sun, mean distance of this planet from the sun. So we have to take we have to take the mean of the distance from the sun. So mean distance is small r, capital T is the period of revolution. So what is mean by period of revolution? To complete one revolution, the time required by the planet to complete a single revolution around the sun is called as capital T, that is period of revolution. So we will state the law, third law. Period of revolution, square of period of revolution of a planet is directly proportional to the cube of mean distance from the sun, and it is the mean distance, suppose it is r, period of revolution is t, time required to complete one complete revolution around the sun. So we have to remove the proportionality sign, we have to take equal to, and we have to take here k, and like this. So where k is a constant, where k is constant. So here k is a constant, and we can write down like this, t square by r cube equal to k, and we have to use this value of k in Newton's inverse square rule. How this law helped Newton to use the inverse square rule and to study the universal law of gravitation. So this is about the Kepler's third law. I will repeat the third law of Kepler. Square of period of revolution of a planet is directly proportional to the cube of mean distance from the sun. So you know directly proportional, meaning of direct proportional, indirectly proportional. So as the distance increases, time required for the revolution also will increase. So that is both are increasing, that is directly proportional. So it is no need to tell, but I am explaining for the law. The square of period of revolution of a planet is directly proportional to the cube of mean distance of a planet from the sun. So in this way we have to use this value of k in as a 1 by k. If we are going to take 1 by k, we have to reverse this value, so r cube by t cube, and we have to use for Newton's inverse square rule, and that we will see in the an important law of universal law of gravitation we will see in the next lecture. Thank you.